Ever wondered what really goes into the foods we love to snack on? Those shiny jars of applesauce, those buttery cookies that melt in your mouth, or the chocolatey crunch of a Butterfinger bar? You see them stacked neatly on grocery shelves, but behind that familiar packaging lies a world of precision, flavor engineering, and fascinating science. Some people say store-bought snacks are just sugar bombs loaded with preservatives, but what if there's more to the story? Today we're peeling back the curtain and stepping straight inside the factories that turn fresh fruit, grains, peanuts, and cocoa into some of America's favorite treats. And trust me, what you're about to see will change the way you look at that sweet spoonful or crunchy bite forever. It all begins in the orchard, where the sweet aroma of ripened apples fills the late summer air. These orchards are alive with rows of red, green, and golden apples glistening under the sunlight. Contrary to popular belief, the apples used for applesauce aren't the leftovers no one wants. They're carefully handpicked to ensure each one is bruise-free and bursting with natural flavor. Farmers know that the best applesauce starts long before the factory. It starts with healthy trees pollinated by the bees that keep entire ecosystems alive. Without them, there would be no apples, no orchards, and certainly no applesauce. Once the harvest is complete, the apples are carefully packed and sent to processing facilities under temperature-controlled conditions to preserve that crisp, farm-fresh quality. Inside the factory, massive conveyor belts carry thousands of apples through an intense cleaning process. You might imagine a quick rinse under tap water, but this is high-tech food safety in action. The apples are scrubbed with gentle brushes and rinsed with purified, ozone-treated water to eliminate bacteria and pesticide residues without leaving a trace. It's the same type of sterilization process used in advanced food industries to make sure the product remains as natural and pure as possible. After cleaning, each apple goes through a decoring and slicing process. Machines precisely remove the stems, seeds, and centers, not because the seeds are particularly dangerous, but because their compounds can affect the taste and texture. Every apple is trimmed and prepped for the next stage, ensuring only the smoothest pulp makes it into your favorite jar. The leftover peels and cores aren't wasted either. They're often repurposed as nutritious feed for farm animals, part of a sustainability effort that minimizes waste at every step. Then comes the magic moment. The apples are mashed in powerful industrial grinders that turn the fresh fruit into a velvety pulp. This mixture slowly cooks down, thickening into that familiar smooth, fragrant applesauce we all know. Factories carefully monitor the temperature to preserve the apple's natural sweetness without burning or overcooking. Once it reaches the perfect consistency, it's cooled and transferred into sterile containers. Vitamin C is sometimes added to prevent browning, keeping that beautiful golden hue while offering a healthy antioxidant boost. The result? A perfectly balanced applesauce that's sweet, tart, and naturally delicious. No mystery ingredients, just the real deal. Now let's switch gears from fruit to flour. Every delicate cookie you've ever enjoyed, those buttery leaf-shaped ones that crumble at the first bite, begins with an unassuming ingredient: soft wheat. The US, Canada, and parts of Europe produce millions of tons of this grain every year. Farmers and millers work together to ensure the flour's texture, protein content, and moisture level are just right, because even a small variation can change how the dough behaves. Once in the factory, the flour is mixed with butter, sugar, and other key ingredients to create a smooth dough. Precision-engineered rollers flatten the dough into perfect sheets before specially designed metal stamps imprint those intricate leaf patterns, veins and all, onto every cookie. To prevent sticking, the rollers are lightly chilled or coated with non-stick materials. It's a mesmerizing sight, thousands of cookies rolling past in perfect symmetry, each one identical to the next. Instead of being placed on trays, they travel on a continuous conveyor belt through massive ovens divided into temperature zones. The cookies bake slowly, evenly, and emerge golden brown with crisp edges and a soft center. But the real challenge comes afterward, transporting those fragile treats without breaking them. That's why every step, from cooling to packaging, is engineered for gentle handling. Even small vibrations are minimized to keep each cookie intact until it reaches your table. Next, we head to the heart of America's candy aisle, where one legendary treat has captured generations of sweet-toothed fans: the Butterfinger bar. Behind that bright yellow wrapper lies an incredible combination of roasted peanuts, caramelized sugar, and smooth chocolate. But it all starts where you might least expect: peanut farms in Georgia, Texas, and other southern states known as the Peanut Belt. The sandy soil and warm sunshine create perfect growing conditions. After 4 to 5 months of careful cultivation, the peanuts are harvested, dried, and trucked to massive processing facilities. Not all peanuts make the cut, only the top-grade ones pass inspection. Trained workers and automated scanners sort through batches, removing any broken or blemished nuts. The selected peanuts are then roasted at high temperatures to bring out their natural oils and signature nutty aroma. As the skins loosen, powerful air blowers whisk them away, leaving behind the golden kernels. These kernels are blanched and ground into a thick, creamy peanut butter, the foundation of Butterfinger's distinct texture. Unlike your store-bought peanut butter, this one isn't too smooth. It retains a slightly gritty texture to give that satisfying crunch in every bite. Meanwhile, sugar beets from the Midwest are transformed into pure white sugar. This process is nothing short of fascinating. The beets are sliced, boiled, filtered, and crystallized until they become the fine granules you recognize. The sugar is then blended with corn syrup and heated to create a thick, sticky caramel base. This molten mixture is poured over the peanut butter, layered, and cooled to form Butterfinger's signature crisp center. Once cooled, conveyor belts move the sheets to the cutting area, where precise blades carve them into perfect bar shapes. But the most irresistible part is next, the chocolate coating. Each crunchy bar passes through a curtain of melted chocolate in an enrobing machine, which coats it from every angle with a luscious, glossy finish. This is where the Butterfinger truly comes to life, that perfect marriage of crispy peanut core and creamy milk chocolate. The bars are cooled to set the coating, then wrapped, sealed, and boxed for distribution. It's an incredible balance of science and indulgence. Fun fact: Butterfinger once released mini versions called Butterfinger BBs in the 1990s, bite-sized chocolate balls that became instant nostalgia for anyone who grew up during that time. Sadly, they were discontinued because they melted too easily during shipping, but their legacy lives on among fans who still crave their return. Now let's fast forward to a different side of the food industry: automation. The way factories today handle massive-scale production is nothing short of futuristic. Take pizza, for example. Once upon a time, every pizza had to be manually topped with sauce and cheese. But today, robotic sauce dispensers precisely spread tomato sauce across dough at lightning speed. No mess, no waste, just perfect coverage every time. These machines can produce hundreds of pizzas per hour with exact consistency, ensuring every bite tastes the same from coast to coast. It's technology that marries efficiency with taste, redefining how your favorite fast foods are made. The same innovation can be seen in ice cream factories. Massive steel machines churn and freeze the mixture while maintaining an ultra-smooth texture. Automated systems then swirl in flavorings, nuts, or chocolate chips at precisely timed intervals, ensuring even distribution. It's why every scoop feels creamy and rich without icy chunks. And when you move down the production line to the packaging section, robotic arms scoop, seal, and stack containers at a pace no human could match. Yet, even with all this automation, there's still an artistry to it, the delicate balance between machine precision and human taste testing. Ever noticed how perfectly seasoned your favorite chips are? That's not luck, it's engineering. In giant industrial lines, freshly fried chips tumble through rotating flavor drums where automated sprayers dust them evenly with seasoning powder. These machines are so finely tuned that they ensure every single chip carries the same flavor intensity, avoiding over or under seasoning. The chips then glide through cooling tunnels before being sealed in nitrogen-flushed bags to preserve crunch and freshness. What reaches you on store shelves is the result of years of research in food preservation, airflow, and packaging materials, all so that the snack stays crisp even weeks later. When you take a step back, it's pretty amazing. From orchard to oven, from peanut farm to candy bar, and from dough mixer to robotic sauce dispenser, the world of modern food production is a perfect blend of tradition, innovation, and care. It's easy to assume that mass production means poor quality or excessive sugar, but that's not always true. The best factories across America are constantly evolving, embracing sustainability, reducing waste, and enhancing food safety while maintaining the taste we love. Imagine standing inside a massive snack factory where the air smells of toasted wheat and savory seasoning. Conveyor belts stretch as far as the eye can see, carrying freshly fried chips that gleam under bright factory lights. The sizzling sound fades into a rhythmic hum as these golden chips tumble into the flavoring drum, a mesmerizing rotating cylinder that seems to coat every piece with magic dust. The airflow is carefully calibrated so the chips don't break, while each delicate rotation ensures that every single bite is perfectly seasoned. Watching this process feels like witnessing the perfect harmony between science and flavor. This is how some of the most irresistible snacks in the world come to life, and once you start eating them, you know stopping is impossible. That's the beautiful, dangerous truth of a perfectly made chip. Now, Let's rewind and follow the journey of another popular Korean snack that has taken over taste buds across Asia and beyond. It all begins with stretchy dough, soft, elastic and fragrant with butter. It's kneaded, rolled out, and cut into tiny pieces kind of like miniature pizza doughs, except these will transform into crispy little clouds of joy. Inside massive industrial ovens, each piece puffs up, golden brown and crunchy, like bite-sized baguettes made for your fingertips. They're lighter than crackers yet far more addictive, with a texture that snaps and melts on your tongue in seconds. You tell yourself you'll have just a few, but before you know it, the whole bag is gone. That's the power of a snack designed to be as irresistible as it is simple. But what really makes them so delicious? Sure, there's salt, sugar, and spice, but the real secret lies in the perfect balance between flavor and texture. Some versions come as buttery cookies filled with a burst of fruity jam in the center. Think of a crisp outer shell giving way to a soft, tender middle, releasing a wave of strawberry or apricot sweetness. Each bite is a tiny explosion of nostalgia, the kind of flavor that reminds you of home-baked desserts but with the convenience of a store-bought treat. That jam, by the way, isn't just any jam. It's a blend of high-quality fruit purees like strawberries, raspberries, and sometimes even apricots or peaches, cooked down until thick, glossy, and rich. That's why these snacks never taste artificial. They're balanced, crafted, and engineered for pleasure. The same precision and artistry apply to something completely different: canned meat. You might love it, hate it, or simply find it weirdly fascinating, but there's no denying Spam's place in food history. Spam is one of those rare inventions that was born out of necessity but went on to become a cultural icon. To understand its story, we have to travel back to the 1930s, when refrigeration was rare and fresh meat spoiled quickly. Families needed something reliable, something they could keep on the shelf and cook in minutes. That's when Hormel Foods, a Minnesota-based company, saw an opportunity. They realized that if they could preserve pork in a way that stayed flavorful and safe for months, they could revolutionize how people ate. Pork shoulder, an overlooked cut of meat at the time, became the hero ingredient. It was inexpensive but rich in protein and flavor, the perfect candidate for innovation. So, Hormel combined pork shoulder and ham with just the right mix of water, salt, sugar, and sodium nitrite to keep it fresh. The result? Spam, a shelf-stable, ready-to-eat meat that could feed families during tough times. The name's origin is still debated. Some say it stands for spiced ham, others believe it was simply chosen in a naming contest. Whatever the truth, Spam became a global phenomenon. Over the decades, it adapted to fit different cultures. In the US, it's classic pork. In the Philippines and South Korea, it's a beloved breakfast staple. In Muslim-majority countries, Spam is made entirely from beef to fit dietary laws. Wherever it goes, its purpose remains the same: to make protein accessible, tasty, and long-lasting. The making of Spam is both scientific and strangely satisfying to watch. Large meat processors grind cuts of pork or beef to an exact consistency before transferring them to huge mixers. Here, water, salt, and curing agents are added. Sodium nitrite, while controversial to some, is essential. It prevents bacterial growth and gives Spam its signature pink hue. The mixture's texture is key. It's not quite a liquid but soft enough to be pumped through industrial filling machines. Every step is carefully controlled to remove air pockets, which could otherwise cause uneven texture or spoilage. When sealed, the cans are cooked at high temperatures, creating a natural gelatin from the meat's own proteins. This clear, wobbly layer you see when opening a can isn't an additive. It's just nature doing its work, helping keep the meat moist and tender. Once cooled and labeled, thousands of cans roll off the line every hour, ready to ship worldwide. It's a mix of tradition, chemistry, and technology, and somehow, it still finds its way into everything from army rations to gourmet Hawaiian sushi. And just when you think you've seen enough of the industrial food world, another everyday essential takes the spotlight: tissue paper. You use it without a second thought, but have you ever wondered how something so soft and thin starts as a tough tree trunk? It all begins in managed forests where trees like eucalyptus, pine, and spruce grow. These species are chosen for their unique fiber properties. Eucalyptus provides short, silky fibers that make the tissue soft, while pine contributes strength with its long fibers. Once mature, machines that look straight out of a sci-fi movie cut and stack the trees in seconds. The logs are stripped of bark, chopped into chips, and fed into a massive pressure cooker called a digester. Inside, a cocktail of chemicals, mainly sodium hydroxide and sodium sulfide, breaks down lignin, the natural glue holding wood fibers together. What's left is pulp, a mushy, fiber-rich mixture that becomes the base for all paper products. Next, the pulp goes through washing and bleaching to remove impurities and achieve that clean, white appearance we associate with premium tissues. The transformation from dull brown to bright white happens through careful refining. Each fiber is reshaped and softened until the mixture feels almost like liquid cotton. But at this stage, the pulp is still 99% water and only 1% fiber, so massive drying systems come into play. The pulp spreads evenly across a fine mesh conveyor that allows water to drain away while forming a uniform mat of fibers. Then comes the magic of drying. Enormous heated rollers evaporate the remaining moisture, leaving behind a thin, delicate sheet of paper. Before rolling it up, the tissue passes through perforation machines that create those neat tear lines we use daily. Then comes embossing, one of the most underrated steps. Embossing presses tiny air pockets between layers, giving the tissue that soft, cushioned feel without adding thickness or weight. It's an illusion of luxury made possible by clever engineering. Some factories even produce coreless rolls to reduce cardboard waste, making the product more eco-friendly. After this, the tissue sheets are rewound into massive logs before being sliced, wrapped, and stacked into the packages you find on store shelves. Not all tissues are created equal, of course. The softest, most luxurious brands use high-grade eucalyptus fibers and carefully refined pulps. Cheaper versions might include recycled fibers, which tend to be shorter and coarser, resulting in a rougher feel. Still, each serves a purpose, from industrial wipes to facial tissues, napkins, and toilet rolls. Even the folding process for facial tissues is an art. They're layered and interlocked so that when you pull one, the next one pops up perfectly. It's all part of a silent dance of precision that happens millions of times a day, unseen but essential. From crispy chips and buttery jam-filled cookies to canned meats and soft tissue rolls, each product's journey tells a story of human ingenuity. Behind every snack you munch on or every product you use daily lies an incredible blend of biology, chemistry, and mechanical design. These modern factories don't just produce food or paper. They represent how far we've come in turning raw, natural resources into safe, convenient, and often delicious essentials. So, next time you open a bag of chips or grab a roll of tissue, take a second to imagine the unseen orchestra of machines, workers, and science that make these everyday miracles possible.